One of the interesting things about what we do at the university in oil sands research is we train the next generation of people in the technology. A big part of the impact is actually the education of these students, and they go out and start looking critically at what they're doing when they work in the industry. Alberta has huge oil sands resources. About 20% are in mineable form, about 80% are too deep and are available by in situ production. But the mineable oil sands need the most help with new technology. So we're interested in mining, extraction, and upgrading of the mineable oil sands to get reduced environmental impact, reduced greenhouse gas emissions, better reclamation of the mine sites, anything we can do to improve the sustainability of that resource. One major theme is what we call non-aqueous extraction. One of the biggest problems that the industry faces is using fresh water to extract the bitumen from the oil sands, which generates wet tailings. And the tailings are what gets the most negative publicity and has the biggest environmental impact. Our approach to non-aqueous extraction is not to use water in the first place. We're looking at solvents and other chemicals to try and extract the bitumen without water, giving nice dry material that can go right back into the mine. Second theme is what we call fundamentals, that we need to understand much better the bitumen, the clays, how they interact, all of the different components of this very complex system. So we have basic scientists working at the University of Alberta and across the country trying to understand how these materials behave and how they interact in order to lead to new ideas and new technologies.
The bitumen is simply coated on the sand grains naturally. As soon as it came in contact with water, it starts to shrink down first, starts to recede, forming bitumen droplets. As soon as you have an agitation action, which the industry has, these droplets will eventually rise up and will be collected as a froth.
We have water inside the cell, and then we add oil sand under the agitation by mechanical stirs here. And then we open the air valve here to let a little bit air in, and air will lift the bitumen from the sand and then separate them.
This is the first time research has been done directly to see the internal mechanisms of bitumen recession directly from an oil sand, and to understand the kinetics behind what really happens in oil sands extraction, how the oil comes out, and how can we improve it with better environmental conditions and better environmental possibilities.
Third area is what we call upgrading, which is processing of bitumen in order to make higher value products. An example of a project there is looking at new additives that would be able to help the cracking process. What you will see is bitumen samples being heated in a couple of seconds to 500 degrees centigrade. And at that temperature, the large molecules decompose and fall apart. They crack, is what we call it, bonds break, and we make smaller products which will come out as vapor. And finally, we're doing work on minimizing the environmental footprint. Most of our work is going back to the processes, coming up with new methods that give production without an environmental impact.
By adding the chemicals or by changing the temperature, the time for the air bubble attached to the bitumen is shortest. And in this way, you can lift most of the bitumen in the system, and then you get the very clean tailings for the disposal. So then you get the high recovery and less environmental problems.
The hardest part about research is that for every 10 ideas that you think are really promising, you may get one or two that turn out. So it's a case of always trying new ideas, seeing if they work, but you do have to be patient because it takes time and it takes a lot of effort to go through what look like promising leads and see whether they really take you anywhere. I think what you'll see is much faster reclamation, smaller mines, less tailings, less accumulation of impact on the local environment in the Fort McMurray area. That's what we think is possible, and the industry is clearly moving in that direction.